All right, let's see if we can analyze and then graph this function, y equals 3 sine of 2x minus pi. First things first, we know that to accurately see the phase shift, we need to put this thing in factored form. So I'm just going to do that right away. So I'll say this is 3 sine 2 parentheses. And then x, let's see, and if we factor a 2 out of this, it becomes not pi, but pi over 2. Okay, so let's analyze it first and then work on graphing it. So let's talk about amplitude and period and phase shift. Normally I would write vertical shift on here as well, but this one has no vertical shift, so I just won't jot that down. So the amplitude, again, easy to see right there. Amplitude is 3. The period, keep in mind this number 2 right here. Period is 2 pi divided by omega, 2 pi divided by 2. So period would be 2 pi divided by 2. So the period would just be pi. And then the phase shift, which we can accurately see in this form, the phase shift is pi over 2. Pi over 2. And when you just write pi over 2, it's understood that it's to the right, and negative pi over 2 would be to the left. But I'll just make it clear there. Okay, so we're talking about a sine function with no vertical shift, and it has these 3 other transformations. So we should be able to just pretty much draw that. Okay, so the phase shift is pi over 2 to the right, so I am going to start my sine graph at pi over 2. And really, at this point, knowing it's got no vertical shift, I can pretty much just say it's basically going to look like that. That's one period of sine. I just need to get the right numbers attached to the scale here. So if the period is pi, then if the period starts here at pi over 2, then it will end. It'll end. It'll end one period later. So from pi over 2 plus pi is 3 pi over 2. So there's the beginning and the end of the period. And if you need to figure out other points like what's in the middle right here, you can say halfway between 1 pi over 2 and 3 pi over 2 would be 2 pi over 2, or just pi. And you can figure out the high point and the low point. But anyway, so that's that. We also have an amplitude of 3, so we know that the highest it goes is 3 and the lowest it goes is negative 3, and that is a full graph of the original sine function. I should just point out here that if we wanted to graph something like, if we wanted to graph y equals 3 cosecant of 2x minus pi, you will recall that cosecant is 1 over sine. So if this was the original problem, if we wanted to graph cosecant, I would have gone back and said, what does the associated sine function look like? I would have graphed this red stuff right here. And then the only things I would have needed to do to make it cosecant, which I'll just do now, are to say it should bounce off of that, it should bounce off of that, it should have an asymptote right here at pi, it should have an asymptote at 3 pi over 2, and it should have an asymptote at pi over 2. In other words, it should have an asymptote everywhere that sine is 0, because cosecant's 1 over sine. So if sine is 0, cosecant is 1 over 0, undefined asymptotes. So there's your graph of 3 cosecant 2x minus pi, and we got 2 examples for the price of 1.